All right, let's get right into it. Think about all the apps and services you use every single day. We just expect them to work, right? But behind that smooth experience, there's this hidden world of engineering designed to prevent total disaster. Today, we're going to pull back the curtain on that database safety net, a concept called high availability. You know exactly what I'm talking about, right? Those services you use for banking or streaming your favorite show or getting work done, they're just always on. They feel completely unbreakable. So how do they do that? How do they pull off that level of reliability?
And then there's the other side of the coin. We've all been there, that heart-stopping moment when an app just dies on you right when you need it the most. You're trying to upload a file, make a payment, whatever. It's so frustrating. And you know what? It's not just bad luck.
The secret, the real difference between something that's rock solid and something that's, well, not. It's usually buried deep in the architecture, specifically in how its database is protected. There's this concept that acts like a safety net, always there, ready to catch the system before it even has a chance to hit the ground.
So this whole safety net thing, it's built on a principle called high availability, and you can think of it like a promise. It's a promise that your data is safe and that your application is going to stay online even when things inevitably go wrong. So what exactly is high availability, or HA for short? Well, at its core, it's all about design. The whole goal is to hunt down and eliminate any single point of failure. You know, that one weak link that could bring the whole system crashing down. If one part breaks, the show goes on. And maybe most importantly, it guarantees that any data you've saved, any committed data, is never, ever lost. Period. The way this works is actually brilliant, and it's simpler than you might think. You have your main server, the primary, that's doing all the heavy lifting. But shadowing its every move in real time is a perfect synchronized backup, a standby replica. It's kind of like a lead actor on stage and their understudy in the wings who knows every single line and every move, ready to step in without anyone in the audience even noticing. Now check this out. This is the secret sauce for keeping data safe. When your app tries to save something, the primary server doesn't just write it down and say, okay, we're good. No way. First, it instantly sends that change over to the standby replica. The standby then has to radio back and say, yep, I've got it. It's safe over here too. Only after it gets that confirmation does the primary finally tell your app, okay, the write is complete. That little two-way handshake is the key to guaranteeing zero data loss. Right, but you know how it is in tech? There's never just one way to do things. It's not a one-size-fits-all solution. There are actually a couple of different ways to set up this safety net, creating two distinct flavors of high availability, and each one has its own strengths. Now, to get these two flavors, you first have to understand what an availability zone is. Just imagine a massive tech campus. An availability zone is like one of the buildings on that campus. It's got its own power, its own cooling, its own network. It's totally independent. That way, if one building has a blackout, all the other buildings on campus just keep humming along. And this right here perfectly illustrates the two approaches. With zonal HA, your primary and standby servers are in the same building. It's super fast because they're right next to each other, and it protects you if, say, a single server fails. But with zone redundant HA, you put your standby server in a completely different building on campus. It's a tiny bit slower because of the physical distance, but now you can survive an entire data center outage. It all boils down to a fundamental trade-off. Do you want maximum speed or maximum resilience? This chart really puts that trade-off into perspective with a hard number, the uptime guarantee, or SLA. Zonal HA gets you 99.95% uptime, which is fantastic. But zone redundant HA gets you 99.99% uptime. I mean, look at that. That tiny, tiny difference of 0.04% can mean hours less potential downtime over the course of a year. For those absolutely critical apps, that difference is everything. All right, enough theory. We get the concept. But what happens when disaster actually strikes? Let's take a look at how this whole system springs into action during a real-world failure. Okay, this is where the magic happens. The second the system detects that the primary server has gone down, an automatic process just kicks right in. In about 60 to 120 seconds, so a minute or two, the standby replica is promoted, and it becomes the new primary. Your app reconnects, and honestly, your users probably won't even notice anything happened. And get this, in the background, the system is already spinning up a brand new standby to protect the new primary. It's this incredible self-healing process. But look, this level of protection, it's not free. There are always trade-offs. Remember that safety check we talked about?
confirming every write on the standby, that adds a tiny bit of extra time or latency to every single save operation. Also, that standby is just a backup. You can't use it for other stuff like running reports. And while the failover is fast, it's not instant, and even planned things like server upgrades can still cause a few moments of downtime. And of course, you don't just set this up and hope for the best. These systems are watched like a hawk. Engineers have dashboards where they can see the real-time status of everything. Is it healthy and synced up? Is it in the middle of a failover? Is it building a new standby? Having that visibility is absolutely key to trusting that the system is doing its job. So far, we've been talking about protecting against one server failing, or maybe even a whole data center going offline. But what if something bigger happens? I mean, what if an entire geographic region has a bad day? Well, that calls for a whole other level of protection. And this right here is a super important distinction. High availability, or HA, is all about surviving local problems with almost no downtime. Disaster recovery, or DR, is about surviving a massive, widespread catastrophe. Think hurricanes, massive power grid failures. The main goal there isn't just avoiding downtime, it's about being able to get back online at all. And this is the ultimate data safety net. Just look at that number. With geo-redundant backup, your backups are automatically copied to a completely separate region, hundreds, maybe thousands of miles away. The durability it's just staggering. 16 nines. It basically means the odds of actually losing your backup data are so small, they're practically zero. This is how you survive a true regional disaster. But what if you need to recover even faster? What if restoring from a backup, even a remote one, is too slow? For that, there's another tool, cross-region read replicas. It's basically that same standby server idea we talked about before, but this one is located in a completely different part of the world. If your primary region goes down, you can manually promote this replica to become the new primary and get your whole application back online, far, far away from the disaster zone. Wow, okay, so we've covered a ton of ground here, from a single server failing all the way to cross-continent disaster recovery. Which brings us to the final and most critical question of all. With all these options on the table, how do you decide what's right for you? And here's the real key takeaway. There is no single best answer. It's always a balancing act. You have to weigh performance, cost, and resilience. For example, a little test database might not need any high availability at all. An app that needs to be super fast might choose the quicker zonal HA. But a mission-critical banking service, you better believe it's going to require the full zone redundant HA, plus a comprehensive disaster recovery plan. It's all about matching the protection to the job. And that really leaves us with this one question to ponder. Whether you're building an application or just relying on one, it all comes down to this. How much is a single moment of downtime worth? For some, a minute of being offline is a tiny annoyance. For others, it could literally cost millions of dollars. And answering that question for yourself, well, that's the very first step in building a truly unbreakable system.